Hello dear students, this is grade 12 mathematics lesson on unit 3 introduction to differential calculus. On today's lesson we focus on derivatives of combination function. So after completing this lesson you are expected to find the derivative of combination functions. Now let's continue to the lesson. Before directly going to deriving combination function, first let's see one theorem. A theorem says if f is differentiable at a, then f is continuous at a, which means that differentiability implies continuity. Let's prove this theorem. Suppose f is differentiable at a, then the derivative of f at a is equal to the limit of f of x minus f of a over x minus a, where x approach to a exists. So observe that for x different from a, f of x minus f of a, this is equal to it is f of x minus f of a over x minus a times x minus a, because you can cancel these two. You will have this one. These two are equivalent. Now the limit of this one, the limit of f of x minus f of a, where x approaches to a, is equal to the limit of this part, which is equal to this, the limit of f of x minus f of a over x minus a times the limit of x minus a, where x approaches to a. So this implies the limit of f of x minus f of a, this is equal to the limit of this part, as you can see, the limit of x minus a, where x approaches to a, this part will be is 0. Therefore, when you multiply 0 by this part, the right side part will be 0. Therefore, the limit of f of x minus f of a, where x approaches to a, is equal to 0. So from this, you can see that the limit of f of x, where x approaches to a, is equal to it is f of a. You can just take this to the other side. So the limit of f of x minus f of a, where x approaches to a, is equal to 0, means the limit of this one and the limit of this one are equal. Therefore, the limit of f of x, where x approaches to a, is equal to the limit of f of a, since f of a is constant, it's itself. Therefore, the limit of f of x when x approaches to a is equal to f of a. So this shows us f of x is continuous at a. So we can conclude that if f is differentiable, then it is continuous. Differentiability implies continuity. But the reverse, the converse is not true. Continuity does not imply differentiability. I can just show you this through example. If you take a function f of x is equal to absolute value of x, the graph of this function, it is like this. F of x is equal to absolute value of x is continuous at x is equal to 0. It is continuous at x equal to 0. But it's not differentiable at this point. Since the graph has a sharp corner, it's not differentiable at that point. Therefore, continuity does not imply differentiability, but differentiability implies continuity. So this is it. Now let's continue to the next part. Now let's see this one. If f and g are differentiable function, then f plus g and f minus g are also differentiable. They are also differentiable. And the derivative of f plus g of x is equal to simply the derivative of f plus the derivative of g. And the derivative of f minus g is given by simply it is the derivative of f minus the derivative of g. So let's see the proof of this. So look this one. F plus g derivative of x, this means it is the limit of f of x plus h plus g of x plus h minus f of x plus g of x over h, where h goes to 0. I hope you remember this one. The derivative of a given function, f of x, it is given by simply it is f of x plus h minus f of x over h, where the limit of this function h goes to 0. This is the definition of derivative. So using this definition, f plus g derivative of x means it is the limit of, just in place of x put x plus h, so this becomes f of x plus h plus g of x plus h, minus f of x means this function itself, so this it is f of x plus g of x over h. Okay. So from this I can write this expression in this form: the limit of f of x plus h minus f of x together, f of x plus h minus f of x over h, plus the limit of g of x plus h minus g of x over h. I can write in this form. So this is the limit of f of x plus h minus f of x, where h goes to 0, is the derivative of f at x. So f derivative of x plus this one is also g derivative of x. So this completes the proof. Therefore here, if we have a function f plus g, to find its derivative, simply you can differentiate or derivate each function and you can add. So this completes the proof. Now let's continue to the next part. Now let's see this example. Let h of x is given to be it is e raised to x plus cos x minus 4x cubed plus sin x. Then you are asked to evaluate h derivative of x and h derivative of this function at 0. So let's do it together. H derivative of x means you can differentiate individually each function. Therefore, h derivative of x means it is e raised to x derivative plus cos x derivative minus 4x cubed derivative plus sin x derivative. This is it. Therefore, this is equal to e raised to x derivative is equal to itself. It's e raised to x. The derivative of cosine of x it is minus sin x. It is minus sin x minus the derivative of 4x cubed is equal to, it is just take 3 times 4, it is 12, and this is x squared. So the derivative of this expression is this minus 12x squared plus the derivative of sin x, it is cos x. So h derivative of x is equal to this one. Next, we are asked also to find h derivative at 0. So let's put 0 on this function. Therefore, h derivative of 0 is equals to, you put 0 in place of x. So you have here it is e raised to 0 minus sine 0 minus 12 times 0 squared plus cosine of 0. Therefore, this equal to e raised to 0 is this 1, and sine 0 is 0. 12 times 0, it is 0. Cosine of 0 is 1. Therefore, when you add this, you get 2. So this is the answer. Now let's continue to the next part. Now let's see this one, the derivative of a product. If f and g are differentiable function, then f times g is differentiable, and f times g derivative is equal to f derivative of x times g of x plus f of x times g derivative of x. So now let's see the proof of this theorem. Proof: f times g derivative of x, this means using the derivative definition, this is equal to this, the limit of this f of g at x plus h, that's this one, f of x plus h times g of x plus h minus f of x itself, or it is f times g of x. So f times g of x means this f of x times g of x over h, where h goes to 0. So now this expression is equivalent to this one, because here f of x plus h times g of x plus h is here. I subtract this one minus f of x g of x plus h and add this here. So the sum is 0. So it is equivalent to the above expression. Therefore here this plus f of x times g of x plus h, and this one it is minus f of x g of x over h. Now next to this we have this one. Factoring here g of x plus h, we have g of x plus h. So factor g of x plus h, the remaining part will be this here, f of x plus h minus this part. Okay, we factored this, we factored out this one. So the remaining part will be this f of x plus h minus f of x. So we have here f of x plus h minus f of x times g of x plus h. And from this part, let's factor f of x. When you factor f of x, because we have f of x here and there, so factoring f of x, the remaining part will be this g of x plus h minus g of x over h. So from this, you'll have this one. This will be this, the limit of f of x plus h minus f of x over h times this part, the limit of g of x plus h, where h goes to 0, plus from this part we'll have this one, the limit of f of x, where h goes to 0, times this part, the limit of g of x plus h minus g of x over h, where h goes to 0. We'll have this one. So I hope you know this one. This part will be this f derivative of x, this part, and this one. When h goes to 0, this becomes 0. So you will have g of x here, plus the limit of f(x) where h goes to 0. This is independent of h, so it is constant on h. Therefore, its limit will be this f of x itself, times this part, it is the derivative of g at x. Therefore, you'll have this one. This part is, it is f derivative of x. This one, it is g, plus this part, it is f of x, times this will be this g derivative of x. Therefore, this complete the proof. So simply, to find the derivative of a product function, simply take the derivative of the first function and multiply it by second, plus, and then write the first function and times take the derivative of the second function. So this is how we just derive a product of two functions. Now let's see example for this. So let's take this one. F of x is equal to x cubed ln x. Then we are asked to determine f derivative of x and f derivative of this function at 1. Now let's see this. Solution. F derivative of x, this function is a product of two functions, so applying product rule, we'll have this one, the derivative of the first function times the second plus the first function times the derivative of second function. Therefore, this is equal to the derivative of this will be this 3x squared times ln x plus x cubed. The derivative of ln x, it is 1 over x. Therefore, simplifying this, you will have this one, 3x squared ln x plus, when you simplify this, you get x squared. So this it is the derivative of f of x. So the derivative of fx, or you can factor x squared here, factoring x squared, you will have this one, 3 ln x plus 1. Now we are also asked to find the derivative of this function at 1. So substituting 1, you will have this. F derivative of at 1 will be this 1 squared times 3 ln of 1 plus 1. Therefore, you know ln 1 is it is 0. So this part is 0. 0 plus 1 is this 1. 1 times 1 will be 1. So the final answer is this. Now let's continue to the next part. Let's see additional example. Let y is equals to e raised to x times 1 plus x squared tan x. Then we are asked to find dy by dx, or simply the derivative of this function. By the way, for three function, we will have this one. If we have three functions f, g, f, g, h, the derivative of this function will be simply, we can extend product rule for three functions. This will be, it is f derivative times g times h plus f times g derivative times h plus f times g times h derivative. So for for the product of three functions, the product rule will be this the first function derivative, and then multiply by the two functions g and h plus f times g derivative times h plus f times g times h derivative. So applying this formula, we can find the derivative of this expression. Therefore, here dy by dx is equal to the derivative of the first function times 1 plus x squared times tan x plus e raised to x times the derivative of the second function times tan x plus e raised to x times 1 plus x squared times the derivative of the third function. This is the answer. So let's simplify this. So e raised to x derivative, it is e raised to x itself times 1 plus x squared times tan x plus e raised to x, the derivative of 1 plus x squared is it is to x times tan x plus e raised to x times 1 plus x squared, the derivative of tan x is this sec x squared. Therefore, this is the answer. So rearranging this by taking e raised to x into 1 plus x squared as a common, we have e raised to x times 1 plus x squared. So taking as a common these two, you will have this one, tan x plus sec squared x plus this part, is to x, e raised to x tan x. Now, let's see the next part. F and g are differentiable functions where g of x is different from 0, then f over g is differentiable and will be equal to the derivative of the first function times g of x, or second function, minus f of x times the derivative of the denominator divided by the square of the denominator, g of x squared. Now let's see the proof of this. Proof. Now to prove this, look, let's assume f over g of x to be q of x. Let's assume f over g to be q of x. And then let's try to find g derivative of x. So we say it here, we assumed q of x to be this f of x over g of x. So from this, q of x is equal to f of x over g of x. This implies f of x equal to q of x times g of x. So now differentiate this. When you differentiate this, applying product rule, f derivative of x will be equal to this q derivative of x times g of x plus q of x times g derivative of x. So this will be equal to, from this I can solve for q derivative of x because we are seeking answer for q derivative of x. So rearranging this, take this part to the other side, so you'll have this f derivative of x minus this part, it is q of x times g derivative of x over g of x. So you get this one, and then q derivative of x equal to f derivative of x minus q of x as it is, we assumed q of x to be this, minus this itself f of x times g derivative of x over g of x. So when you multiply this, you'll have this one. It is f over g derivative of x. Q derivative of x means it is f over g derivative of x, which equals to this f derivative of x times g of x minus f of x times g derivative of x over g of x squared. So this completes the proof. Now let's see example for this. Let f of x is given to be cot x. Then we are asked to find the derivative of this expression. So to find this derivative, I can write cot x in the form of quotient of two functions. So let's write this in this form. F of x equal to cot x can be written in this form. It is cos x over sin x. So applying quotient rule, I can find the derivative of this function. Therefore here, f derivative of x equal to, applying quotient rule, the derivative of the first function or the numerator times by the denominator minus the function on numerator times the derivative of the function on the denominator divided by the function on denominator square. So simplifying this, you'll have this one, f derivative of x equal to the derivative of cosine is it is minus sine. Therefore minus sine times minus sine is this minus sine squared x minus the derivative of sine x is this cos x. Therefore cos x times cos x is this minus cos squared x divided by sine squared x. So from this you'll have this one, just taking negative 1 outside as a common, you can write this in this form, negative 1 into sine squared x plus cos squared x. Therefore, you know this one. This is using trigonometric identity. Sine squared x plus cos squared x, it's 1. 1 times negative 1 is this negative 1. The numerator part is it is negative 1 divided by sine squared x. So I can write this in as form, this equal to this, the reciprocal of sine function is cosec, so it will be this minus cosec squared x. Now let's continue to the second example. Let's take this function. Let f of x is equal to this 4x plus 5 over x squared plus 1. Then we are asked to find d by dx of f of x. This means it's find the derivative of this function. So applying quotient rule, the derivative will be the derivative of the first function or the numerator times by the denominator minus the function on numerator times the derivative of the function on the denominator divided by the function on the denominator squared. This is it. So from this you'll have this one. The derivative of this function is 4. 4 times this result minus 4x plus 5 times the derivative of x squared plus 1 is 2x. So I have 2x here, 2x times 4x plus 5 divided by x squared plus 1 squared. So simplifying this, you'll have this 1. When you multiply this, you get 4x squared plus 4, and this result is this minus 8x squared minus 10x divided by x squared plus 1 the whole squared. So this will be this 4x squared minus 8x squared is minus 4x squared minus 10x plus 4 divided by x squared plus 1 the whole square. This is the answer. Now, the basic concept that we have seen today is the derivative of a combination function. So, if f is a differentiable function at a, then f is continuous. We have also seen this one. Differentiability implies continuity, but continuity does not imply differentiability. Second part that we have seen is this. The derivative of sum of function is equal to this, the derivative of individual function, and you add or you can subtract. The other one we have seen is the derivative of product function. If we have two functions f and g, the derivative of their product is given by this equation. It is the derivative of the first function times second function plus the first function times the derivative of second function. The other point that we have seen today is the quotient rule. The derivative of f over g of x will be given by, it is the derivative of the numerator times denominator minus the function on numerator times the derivative of the function on denominator divided by the function on the denominator squared. This is it. So this is all about today's lesson. So for you to try, I'll give you exercise. Please try to do these questions. I'll give you 1 minute to copy the question. So I'll see you on the next lecture. Until then, goodbye.